some examples of proving identities. They've got three of them here, and let's just try it. Now, these are your double angle identities here, and I think they're the ones we're going to use in these questions pretty well. And let's just try it. We're going to say, prove that 1 minus cos 2x equals tan x times sine 2x. Well, this question, both sides look a little bit complicated, but they both have some things we could do. Let's take one side at a time. This is just one way you can do it. Let's start with the left-hand side. Now, you've got three different ways you can replace cos 2x, but they chose this one, 1 minus 2 sine squared. And why is that? Because it's really nice to get rid of that 1. See? If I replace cos 2x with 1 minus 2 sine squared, 1 minus 1 is 0, so now the 1's gone. And minus minus, I've just got 2 sine squared x on the left-hand side. Okay, now let's figure out what this right-hand side is. Well, sine 2x is really 2 sine x cos x. But these cos x's are going to cancel, and you're going to get 2 sine squared x. Well, if you can show that the left-hand side and the right-hand side equal the same thing, you've proven the identity. So that's it. Therefore, the left-hand side equals the right-hand side. Three little dots mean therefore. Okay, let's try this question here. Okay, we're going to see if we can prove that cos 2x over 1 plus sine 2x is cos x minus sine x over cos x plus sine x. Well, somehow, we're going to replace those two things. So this one, we start with the left-hand side. And what is cos 2x? It's cos squared minus sine squared. Why is that a good idea? Because we know that that's a difference of squared. Cos x plus sine x times cos x minus sine x. And that's why we do that. Now, the sine of 2x is really 2 sine x cos x. So we know we got to replace that. But how are we going to change this into something multiplied together? Well, now we're going to use the trick that 1 really equals sine squared plus cos squared. Now, that's a little tricky, but you should be able to see that a squared minus b squared, cos squared minus sine squared, is a minus b, a plus b, cos x minus sine x, cos x plus sine x. Now, the only way this thing's ever going to equal this on the right is if this is canceling. So sine squared plus 2 sine x cos x plus cos squared, well, that's just a perfect square trinomial. So it must be cos x plus sine x and cos x plus sine x times itself. See, if you do FOIL on that, you'll get right back to that. Now, what happens? Those guys cancel. And what do you end up with? You end up with the right-hand side. And that's it. Let's look at one more example. One more example. Here they show this one. 1 minus cos 2x over 1 plus cos 2x. And it's the same thing as up there. You've got three things to choose from. What are you going to choose? Well, choose the ones that make that 1 that's in front cancel. Choose the identity that will cancel that number 1. So that's what they do. They go 1 minus 2 sine squared. 1 minus 1 is 0. That's just 2 sine squared there. And the other one, if we make it 2 cos squared minus 1, those 1's will disappear. We'll get sine squared over cos squared, and the 2's cancel. And that's what we're trying to prove. The tan squared x equals the left-hand side. Right, we just proved it. And there you go. There's the whole thing all done.